Hello guys, welcome to another video, and in this video we're going to be doing something very special. We'll be diving into the world of one of the most important concepts in the world of programming, mathematics, even in the whole world as we know it. We'll be diving into the world of matrices, but not this matrix though. Yeah, that Matrix is a movie, and I recommend that movie. Really interesting, very interesting. One of my favorites too. But that's not what we are going to be talking about today. We'll be talking about matrices, their applications, how they even came about, and what they are, how they influence linear algebra, maths, programming, computer graphic, image processing. So this episode is going to be packed with a lot of facts and also historical figures. So let's dive in. What are matrices? This question is very confusing, a very confusing question, and it has a lot of answers. Matrices mean different things to different peoples in different areas, fields, careers. To a biologist, a matrix is a womb, because the actual meaning, the first meaning of a matrix is womb, and it actually came from the Latin word matrix, which actually meant womb. So it was that word was derived from mater. Mater means mother in Latin, so they joined it together to form the womb. So the matrix meant womb in the 1800s, and when people spoke Latin. But now matrix means an entirely different thing. To some people, matrix is a movie. To some people, matrix is a mathematical representation. So a mathematician is a representation of numbers. To a physicist, is a representation of vectors. Even to a data scientist, is like a representation of features and variables. A machine learning engineer will see matrices as a storage of vectors. A programmer, a matrix is like a data structure to him. Then to a computer scientist, is like a representation of information and data. But what exactly is a matrix? What is the standard definition for a matrix? A matrix is an array-like representation of values. So it represents values. Representation can also be storing. It stores values, it organizes them in rows and columns. That's why it's array-like. That's why in programming languages, when implementing matrices, you use arrays. So where the matrices come from? We are going to do a time travel to the 2nd century before the birth of Christ, somewhere in China. So the earliest sighting of matrix was in 200 BC. It was found in a book called the Chinese 9 Chapters of the Mathematical Art, where matrices were used to solve simultaneous equations. Now then, it was not called matrices, but the concept was very much alive, of using this array-like structure to solve simultaneous equation. And it's funny that simultaneous equation is also part of linear algebra. So matrices, from time immemorial, matrices have been used to solve aid with helping scientists and mathematicians solve linear algebraic problems. So then it wasn't called matrices. It didn't really have a name, but it was just a concept. Then a man called Girolamo Cardano, this handsome man on the screen, introduced the matrix method of solving equations to Europe in 1545. So he's actually an Italian mathematician. That's why his name is Cardano. It sounds so Italian. So it's a giveaway. Then Gottfried Wilhelm publicized the use of matrices to store information. Now this was within the 1700s to 1710. So in the 18th century, a lot of things were booming. This guy introduced and publicized the use of matrices to store information. Then came this guy, James Joseph Sylvester. So even though Gottfried publicized the use of matrices to represent information, numbers, records, and the rest of it. This was the guy that actually gave the concept the name matrix. So you can see him as the Adam of matrices. So he gave it the name matrix. Like I said earlier, before matrices were called matrices, a matrix was just a womb. That's what people saw it as. That was the meaning of matrix back in the days when Latin was one of the most spoken languages. The matrix just means womb. So this was the guy that named those array-like representation that we saw in the 9 chapters of the Chinese mathematical art, and the publications of Gottfried of using this array-like structure to store information and store data. He was the one that actually gave it the name matrix in 1850. Yeah, I think he's a British mathematician too. So though there are a lot of other influential figures around the concept of matrices, we have Kali, I think that's Gabriel Kali. We have Cramer, who made the Cramer rule, and it was based on Cardano's introduction of the matrix method to the European world. So Cramer made a rule out of it called the Cramer rule. You can also look into that later. So this was the guy that named it matrices. Now that's it for the history of matrices. In fact, we only have evidence that the earliest written form of matrices was in the 200 BC, but I believe that it dates far back to the use of abacus, because if you look closely, an abacus is like a matrix. It represents beads on rows and columns, and they used it to do additions and subtraction. So you can also call that a matrix because it's also an array-like representation of numbers, and then it was used to do multiplications, addition, subtraction, and the rest of it. Now, what are the applications of matrices? How do matrices affect lives? You might have heard of machine learning. Yeah, machine learning is the art of training models to be able to predict stuff. Even now, they generate stuff, they learn with data and create valuable output from the data which they are trained with. Now, matrices have a lot of impact in the world of machine learning, from neural networks to current networks, even to the transformers that power LLMs. Matrices have a part in it. I don't think there's any part of the computer world you go to you won't see the application of a matrix, be it image processing, where your images are like pixels. Actually, your images are pixels, and these pixels are stored in an n-dimensional matrices. So if the image size is 256 times 256, then you will know that the dimension of that matrix is 256 columns times 256 rows, and each of those columns and rows store a tiny pigment of the picture, a color. It can be black, it can be white, and that way your images are being computed together through that matrix, organizing it and displayed on screens. Then search engines, matrices are used, they power search engines, even Google's search engine. So you notice that when you go to a website, you can see links to another website. Most times there's a matrix working under the hood, organizing related web pages together. And not just that, we see the rise of vector search engines. A vector search engine is just like a database that stores contents in a vector format. So vectors is just like an array of numbers. Now a vector search engine can search it and look for related results or related rows in its database that relates to the input query. Now in a vector database, data is stored as vectors. And remember, in the first definition I gave of matrices, I said that they are a representation of values. And most of the times, to the physicists, to the data scientists, and to the machine learning engineer, a matrix is like a storage of different vectors. So the vector search engine just searches through those vectors and returns related results. So those vectors can also be seen as matrices, showing that matrices also power those search engines, and without matrices those search engines wouldn't even exist in the first place. Then we come to computer graphics, your video games, um, videos, and the rest of it. Matrices are put in place, and the funny thing is that the operations that is carried out per second on each of these matrices is what brings the computer to life. There will be a lot of matrix multiplications under the hood, a lot of scalar multiplications to make sure that graphics shows. Like if you go to a website, you see something wiggle across the screen. What you're seeing is something wiggling across the screen, but what the computer is saying is a multiplication operations happening on the matrix that stores the values of each of those movements. The same thing occurs with gaming. In gaming, matrices play a very large role with ray tracing, with the switching of scenes, with the actions, the events, and the rest of it. Matrices are under the hood. They also influence data science. Like in data science, matrices are used to store variables or features of a data set. So they are stored in dimensions. So an n-dimensional matrix stores different variables and stores different features that can be found in a data set. So matrices touch about 80% of linear algebra, and in fact 99% of linear algebra is centered on matrices. Even maths in its own way revolve a little, especially linear algebra revolves around the concept of matrices. Other than that, even matrices have if impact in fields like rocket science, um, neuroscience, artificial intelligence. We have already seen how it plays a role in LLMs, large language models. So the architecture that powers them also use matrices under the hood. You've heard of the concept of neural networks, and if you look closely, without matrices, you wouldn't really have any neural network. So that brings us to ask, how do we implement a matrix? Well, we are going to be looking into that in our next video. We'll be looking at the operations that can be done on a matrix and how to implement a matrix in Python. So stay tuned for the next one, and thanks for watching.